Welcome back, grade 11s. We've got our last example here where we're simplifying expressions that have exponents in them, or terms that are exponent. I don't know, something. One of them looks like this. And the key questions we've been asking ourselves as we go along is make sure we've got prime bases and count how many terms there are. So I see 9 and 9. Those on prime bases, probably just going to be best to prime factorize those. So 3 to the 2n minus 1 plus, and I want to write 9 as 3 squared, and I still need to raise it to the power of n. And in the denominator, same idea. That's 3 squared, still to the n, minus 3 to the 2n plus 1. Now, you're going to notice by the time we get to the end of this that we're going to take in a lot of steps, and we can not skip one or two of them, but we can start combining steps when we know what we're doing. So in the next step, I'm going, okay, well, great stuff. I need to multiply this n in. So I've got 3 to the 2n minus 1 plus 3 to the 2n. And this is also 3 to the 2n minus 3 to the 2n plus 1. But to be honest, we could have just seen that was coming up anyway and gone, oh, well, 2 times n is 2n. So might have been safe to skip a step there or combine steps. And then the other step to combine, so we could have gone straight to what I'm about to write now, is there are multiple terms, so we must be splitting and factorizing. Well, we need to factorize at least, and to help us get there, we're going to split. So we're going to split that into 3 to the 2n times 3 to the minus 1 plus 3 to the 2n. And in the denominator, similarly, 3 to the 2n is just 3 to the 2n, but this we can split into 3 to the 2n times 3 to the 1. And it would have been a lot easier just to say, you know what, we could have gone straight from what we were given here to this step here and saved quite a bit of time. I can't see, what's our video on? 2 minutes. Okay, well, you wouldn't be talking while you're doing it, hopefully, but you could save yourself a good 30 seconds at least. So let's go from there and say, now we've got that, let's look for our common factor. So common factor in the numerator looks like there's a 3 to the 2n in each of these two terms. So therefore, we can take it out as a common factor. This is on the numerator. So we still need to multiply it by 3 to the minus 1 plus 1. Remember that little trick to go, there are two terms, so there must be two terms in the bracket. Just to remember that this was 3 to the 2n times 1, getting that 1 there. Okay, denominator, let's look for a common factor. And, oh, lo and behold, it happens to be 3 to the 2n as well. It doesn't have to be the same as the numerator, but quite often it ends up being the same. So let's take 3 to the 2n out, and we've got two terms, so we must have 2 in the bracket. So 3 to the 2n times 1 gives us the first term, and we still need to multiply it by 3 to the 1 as our second term. Don't forget the negative, because it was negative here. Okay. The 3 to the 2n's rather conveniently cancel out. 3 to the 2n goes in once, and we're left with 3 to the minus 1 plus 1 over 1 minus 3. Well, again, you can work out that and say, well, it's a third plus 1 is 2/3, 2/3 divided by 2, and all sorts of other things. I don't think I've even got that correct about this. Is actually what a third plus 1 is 4/3, 4/3 over... No. Just plug it in the calculator, because that's not what we're assessing here. But you can do it without a calculator if you really wanted to. And we'll get minus 2 over 3. Okay, well, that's it for simplifying those expressions for now. I think we'll head into equations a little bit later, and I'll see you then. Cheers.